Hello again, and welcome back to another lesson on our CloudNetX course. Today, we're diving into a topic that affects almost everyone, whether at home, in the office, or in large enterprise environments: Wi-Fi performance troubleshooting. Let's begin with signal interference, one of the most common culprits behind poor Wi-Fi performance. Wi-Fi signals operate in frequency bands that are shared with other devices, which means interference can come from a variety of sources. For example, microwaves, baby monitors, and Bluetooth devices can all interfere with Wi-Fi signals, especially on the 2.4 GHz band. Additionally, neighboring Wi-Fi networks using the same frequency can cause congestion, leading to slower speeds and unstable connections. Next, we have signal loss, which occurs when Wi-Fi signals are unable to reach their intended destination. Unlike wired connections, Wi-Fi signals degrade over distance and can be blocked or absorbed by physical objects. Walls, floors, and even metal surfaces can obstruct Wi-Fi signals, making it difficult for devices to maintain a stable connection. If users in one part of a building experience dropped connections, signal loss could be the cause. Unlike signal loss, which occurs due to physical obstructions, signal degradation happens when the Wi-Fi signal weakens as it travels through the air. The further a device is from the access point, the weaker the signal becomes, leading to reduced speeds and increased latency. Low signal strength is another common issue that results in slow speeds and frequent disconnections. It typically occurs when users are too far from the access point, or when the signal is weakened by environmental factors. Symptoms of low signal strength include frequent buffering, slow downloads, and dropped connections. Using Wi-Fi signal strength testing tools can help identify areas with poor coverage. Another major factor affecting Wi-Fi performance is channel overlap. In the 2.4 GHz band, there are only 3 non-overlapping channels: 1, 6, and 11. If multiple access points or neighboring networks operate on the same or adjacent channels, interference and congestion can occur. For example, if an office has multiple Wi-Fi access points configured on overlapping channels, users might experience slow speeds, high latency, or frequent disconnections. Finally, let's talk about Wi-Fi roaming issues. Roaming occurs when a device moves between different access points in a network. Ideally, the transition between access points should be seamless, but in some cases, devices cling to a weaker signal instead of switching to a stronger one. This can lead to poor performance as devices struggle with weak connections, even when a better option is available. In summary, troubleshooting Wi-Fi performance issues requires a combination of analysis, configuration adjustments, and strategic placement of access points. Signal interference can be reduced by switching to the 5 GHz or 6 GHz bands, while signal loss and degradation can be mitigated by optimizing placement and upgrading hardware. Thank you for joining us today, and see you soon.